Okay, this section's on factoring special cases. And as far as I'm concerned, these factoring special cases, you do them the same way that you did the other problems. There's just maybe a thing or two you have to think about a little bit before you can actually work them out. So the first is a perfect square trinomial. The factors are going to be the same, which is not a big deal. I mean, if we just set this up and factor it just like we would any other problem, we'll find out that the factors are the same. So let's look at this. Same as we did in last section, we have this, we're trying to factor it into two binomials. This comes from the first two, which means that's going to be an x. And then this will come from whatever these two are multiplied together. And then remember, we're looking for the combination to add up to that. So if we make a little table, combinations that multiply to 9 would be 1 times 9, negative 1, negative 9. 3 times 3, negative 3 times negative 3, and I think that's it. Now we need combinations that add up to 6. Well, this adds up to 10 and negative 10. There's our 6. So this is the combination that we want. And it just so happens that whenever we figure out that combination, both of them happen to be the same thing. So x plus 3 times x plus 3. Now, if you think about that just for a second, you'll realize that, oh, wait, there's a shorter way to write this. When we have something times itself, we can put it to a power of 2. So since we have x plus 3 times x plus 3, we can write that as a power of 2. So this is a shorter way to write that answer. That's it. If we have a negative in there, we have to watch out for the negative sign and do the same thing. So we're going to split this, x and x. We're looking for multiplied to 49. So 1 times 49, negative 1, negative 49, 7 times 7, negative 7, and negative 7. Find the combinations that add up. We're looking for them to add to negative 14. Well, not the first two, but the last one adds to negative 14. So it's going to be a minus 7 and a minus 7. Again, we want to write that in the abbreviated form with the power of 2. Okay, so that's the one special case. Here is the other special case, and that is where we have, it's called the difference of two squares, and it's where the factors are the opposite to each other. Okay, so here the factors were the same. When we were done, we had the same factor in there. Now we're going to have factors that are the opposite to each other. So we are going to split this to v and v, same as we did before. And we're going to try and split this to something that makes negative 100. Now, multiply to negative 100. Positive 10, negative 10, positive 1, negative 100, negative 1, positive 100. All these combinations multiply to negative 100. Oh, 2 and 50, negative 50, negative 2 and positive 50. Excuse me, 4 and 25, 20 and 5, Whew. Now, the thing is, I want them to add up to what? What is my middle term? What's here in the middle? Nothing. We want it to add up to 0. So if we start adding these, 10 and negative 10 does add up to 0. If you add the rest of these, you are not going to get 0. You'll get everything else. 21. Okay, the combination that gives us 0, you'll notice, is plus 10 and minus 10. Can you write this together with one power like we did on the last problem? No, these aren't the same thing. This is plus, this is minus. So this would be how you would have to write your answer. But we're looking for that combination because there is no middle term. We're looking for that combination that adds up to 0. All right, so for one more of these, we're trying to split this into two binomials. First spot is going to be our s and our s, and then we're looking for combinations that multiply to negative 16 but add up to 0. Well, that's going to be our 4 and negative 4. Okay, we could look at 2 and 8 and 1 and 16, but our positive 4 and our negative 4 are going to be the combination that makes 0 for the middle. Okay, so that's what we're looking at.